So honored to be here, and long-time Istio fan. I can't say I deeply started Istio, but I certainly was an advocate, and it certainly reflects a lot of things we learned internally. I won't be talking much about that today. You might have noticed the cloud is changing a little bit. Kubernetes is part of that, but really what's going on is like old cloud is VMs and disks. That is not a particularly productive infrastructure. That's the right infrastructure for moving legacy things to the cloud and saving some server costs, but it's not actually what we want. What we want is the ability to do something, really with services and APIs, right? We would like to not think about the hardware at all, right? We'd like to use different languages and in particular have different teams work independently. I'll come back to that point a little bit. So it's fine to say everything's going to be a service. What's Istio's role? In my mind, Istio's role is to make a service work well. Sorry? The easy part, I think, is, I want to have everything be a service, but what does it mean to make a service work well? Well, first thing I want to point out is, what is Istio? Because I actually think, generally speaking, people have it wrong. This is from the website. It is true, it does these things: connect, secure, control, observe your services. This is from Lewis Ryan's talk coming up later today. It's a platform to manage service interactions for containers and VMs. That's also true, but I still don't think it's the right view. You could talk about its functionality. That's also true, things it does. But I don't think that's quite right either. The first thing that got my attention is the side effect of having lots and lots of services, right? We run all these billions of containers every day. Those containers are really all parts of services, right? A container is really typically one element of a service that's using lots of containers for throughput. So the first thing I think about Istio is actually in this presence of tens of thousands of services and billions of containers, what I want Istio to be is automate all the things, right? I don't want to know how to do an SLO for service B. I want SLOs to be inherent in all my thousands of services. If I have to think about them one at a time, it's too late, right? I don't want to think about how do I authenticate to a service. I don't want to think about how do I measure a service. Any of these things, right? So the first thing Istio has to do is automate all the things. So that would be one definition, and I think that's closer. It's not really, the previous definitions all tend to think about, they kind of imply a small number of services, right? When I started Google in 2011, we already had 10,000 services. And it's like, we only had 30,000 engineers. So we had like a production service per 3 engineers, right? And I don't know what the ratio is now, but it's probably similar. Right, and I can't figure out why we have 10,000 services, by the way. Right, and assuming the number's 100,000 today, which would make sense scale-wise, I don't know why we have 100,000 services, right? But we do. So that's one definition of Istio that I think shifts kind of how you think about it. But there's one more that I actually think gets at it even better, and I really like everyone to think about it this way, which is my real answer for what is Istio. And it's that it decouples developers from operations. And this is a little bit of a thing to tease apart. What I mean by that is, without Istio or something similar, the way you do policies is you put some source code in your service, right? You write some code that says, oh, here's the access control check. Right? I don't want that code to exist. If you're writing code that here's my access control check, then later, when I want to change the policy for access control, I have to find your source code and change it. And I have to find all the call sites in all the services that do access control and change them all. Then I have to redeploy all the services that I just changed. Right? So to me, the actual long-term thing that makes productivity go up, makes velocity go up, is that we are taking stuff out of the source code, which has all these secondary benefits. It means that the policies can now be consistent across services, because it's not up to individual developers to decide what the policies are, right? It means that I can change the policies while the service is running. I do not have to redeploy the service to change the policy, right? But another one, I think this is really the long-term productivity advantage, is policies don't block launches, right? When you have policies in your source code, you have to go through some kind of launch control, right? You have to go convince your CIO or your security org that your service is safe to launch and that it meets all the policies. Well, guess what? If you don't get to write any policies, you don't have to argue about whether your policies are right or not. It's not your problem, right? That's the decoupling I really am after here, right? And you get that by having these policies in the proxies or any other place that isn't the source code of the actual service, right? So if you ask me what Istio is for, this is what it's actually for. It's for decoupling services, the service policies from the service implementation, and it's also, frankly, for decoupling teams from each other, right? Done well, different services should be able to implement and upgrade independently, right? They shouldn't depend on each other much for actual rollout. That's separate from the main operational decoupling. So that's kind of my first point, is just please think about Istio in its fully grand form of what it's bringing us and why it matters, right? It's not about a service, it's about all the services and where do the policies go. Now, new topic. I want to talk a little bit about something I worry about for Istio, which is that we have, as Larry mentioned, we have a certain structure that makes the internet work. Here's the kind of the OSI model, and then there's kind of the TCP version of it, which is the one that's really relevant here. And we've kind of, after a lot of time, figured out how to separate these layers. And what that matters, the way that looks for something like Istio is, well, we know kind of that the core of Istio is really kind of layer 7 headers, and managing that. We have this plugin model, so we can do application-specific things. That's great. It kind of does layer 3 and layer 4. What I mean by that is there is mechanism in Envoy to do lower layers, but I don't think it's what I see people focusing on, and I don't see it particularly managed in a thoughtful way yet in Istio, right? So I think that's open, but let's talk about a little bit why I think it's going to matter. The first thing why the structure matters is I have different performance requirements and different goals at the different layers. Like at the bottom layer, I really should be looking at a 5-tuple, probably in hardware, and making decisions based on that. That's what we've been doing, by the way, first time I used that would be 1995, and I wasn't the first to do it by any means. And then we certainly know that we want to look at headers in Envoy, right? And I think in practice, people kind of know that Envoy proper looks at headers and Envoy plugins look at payload, but it would be nice to actually make that a more understood distinction, right? Because I actually think that's going to matter for lots of reasons. One reason it matters is that looking at headers and looking at 5-tuples can be done in hardware. Right? And when we look at how we want to do a service mesh at Google scale, if we can't offload to hardware, we don't actually get the throughput we need. Or it just costs us too much. Like if you do a whole bunch of processing of headers in a general purpose CPU on your server in a sidecar, yes, you can do that, but it's expensive. Right? We're already spending, I don't know what the number is, but certainly hundreds of thousands of cores looking at packet headers. Right? Maybe 1 million cores. I don't actually know the number, but it's a large number, right? And my point here is we don't want to force people to do everything in a general purpose CPU, especially for lower layers. And it's easy to cause that to happen if you don't realize that these lower layers might want to go on hardware. Right? So I want you to think about these layers and say, oh, yes, we could all do them in Go, but I don't want you to force me to do them in Go on a general purpose CPU. Right? And it's a slippery slope. It's very easy to add features to Envoy or Istio that will move the whole thing to be roughly impossible to offload except to some other general purpose CPU. And also when you get to Larry's pictures with his access network, the same structure here is going to help his network for the same reasons. Some of his devices that he wants to offload to, it'd be nice if you don't try to do general purpose payload processing on them. Right? Another way to think about this is we want as a goal that these lower layers get handled well. And I think it's not a problem that I don't think it handles it well yet, because the focus correctly should be on layer 7 and getting that right. But I think the community's done a good job at layer 7 and it's going well. And like while we still can, let's also think about a little bit more about layers 3 and 4. So how do you tell if you're doing it right? There's some work going on the eBPF. The B, by the way, is Berkeley, just so you know, Berkeley packet filter. That's basically in-kernel processing of packets. That's a good proxy for things you could offload to hardware, because it uses a restricted language. It's not a general purpose programming language, right? So that's a good thing to use for layer 3, layer 4 things. There's work in the Istio community, really Envoy community, I guess, to do that. Great. Let's make sure that that's a test of our future. If that continues to work, that's a good sign. Can you move stuff to Big Iron, an F5 firewall device? That is great at layer 3 and 4 management. You ought to be able to leverage it. They're already there. Every enterprise network has them. And then finally, can I do stuff with a NIC? There's lots of smart NICs. Network interface cards often have ARM cores on them, right? You could do application processing on them maybe, but it's great clearly for packet headers, right? Looking at packet headers and all kinds of things, even encryption, lots of stuff you can do on those NICs, but not everything. Right? So what's the line about what you can move on to a NIC or not? So in the end, the goal is basically a few things. Are our lower layers constrained enough to make sure we can offload them later and ensure high performance for the long term? And another goal, which is really an Istio goal, is, and again, I don't think we're quite there, but it'd be nice if the policy language, the declarative YAML, is actually broad enough that it becomes the language you use for your firewall, for example. I don't really want to have one language for layer 7 and a different language for the other layers depending on what vendor I have for that device, right? So we have a chance to make a layer 4, layer 3 policy language that's equally good to our layer 7 language, but is also, most importantly, platform agnostic. Right? That should be a goal of the community to say, this is the way you configure your firewall using Istio, but you don't need to know whose firewall it is. Right? Right now, you have to know that, I would say in general. So here's a picture that was done by F5 from the paper cited down here. And I kind of like this picture because it hints at some of these things I just mentioned. So in this case, what they're trying to do is legacy MySQL, which is not really a layer 7 protocol, connecting it into their Envoy mesh. So what they're doing here is they have this F5, which is a big iron firewall, and it can do some various things. But what it's doing here is MTLS from the Envoy mesh to the actual database, right? And what's interesting about this is better than having a dumb firewall policy, which is open these IP addresses. This policy is open this particular MTLS connection from this particular Envoy source. Right? That's the first thing that's interesting about it. Is Envoy is actually managing the F5 in some meaningful way that's better than the policy you would have if you just wrote a simple firewall rule, right? And it could be much more dynamic than that. The next thing that's interesting is the policy here comes from Envoy. So if we had a good policy language for lower layers, you could send it to Envoy. Envoy would use that to then set the F5, right? But the callers to this service don't know that the F5 is there at all. Right, so here we have a model that's mixing layers, mixing hardware and software, but the policy is still coming from one place, deployed in one way. Right, that is super valuable. And finally, this is, I think this again, the dynamic nature of making particular IP addresses show up as MTLS and authenticated, right, through the F5 device. That's a good proxy for many. If you can do that, you can do lots of other things that are interesting as well. You can offload your layer 4 stuff to your Cisco router. You can use special encryption that's off of your normal nodes. So that's one example of why this structuring can be helpful. Here's another example from gRPC. This is called look aside. So by default, right, we're thinking of Istio, most people think of Istio as something you do with a proxy that's in front of your service. In Google, we don't use the proxies all that much, again, because of the performance cost of having this hop and the availability cost. So where we can, we use this model called look-aside, where basically we have some checks and some load balancing decisions, but they're actually pushed into the client. So it's kind of a smart client approach. So the client has some code on its way out to make the call which says, oh, I need to pick a back end to go to, I want to do some health checking, I want to report some metrics, some telemetry, so that we can measure the SLO of this service. But it still has the kind of XDS policy settings, right? It's just that instead of setting the policy in the proxy, we're setting the policies at the collection of clients, right? And that essentially distributes the meaning of the proxy is there in some sense, but it's lots of little tiny proxies at each client. And there's things this works well for. The obvious one we use it for is load balancing health checks. It's good for observation. It can be good for ACLs. That's a maybe because you have to trust the client. If you don't trust the client, you can't do access control there. But in many cases in Google, the client is itself trusted code, and we can do access control there. Certainly things like authentication can work, XDS can work. The one thing you have to be careful of is, again, you can't put arbitrary plugins in these clients, right? You wouldn't want a big, heavy payload plugin like an API gateway or something running on each client, right? That's the wrong model. So again, the layering structure matters here. What are the constraints such that it's safe to use look-aside? Right, so right now, I think you can do look-aside in this model, but you have to, you're on your own to make sure that whatever you're asking the client to do is reasonable. Right? There's no guidelines for that, basically. And finally, I think it's important to realize in this picture, there's not even any sidecars. Right? In the gRPC case, it's actually, these extensions are built into the gRPC client, and so it's no sidecar and no middle proxy, and again, that gives you a good foundation for performance. Now, what if you do want an API gateway? Well, then you actually combine these techniques. You can use a smart client for load balancing, health checking, and things like that. And then you still use a middle proxy, but now the middle proxy is only needed when you're doing heavy data payload things like API gateways, right? Things that you don't want to move to the client. And a good test for this is, would you be able to run this on an Android client, right? gRPC will run on an Android client. You can push your observation data collection all the way to the phone, right? But you're not going to push your API gateway to the phone, right? That wouldn't make any sense. So you need to have some thoughtfulness about this look-aside model in particular, but it's really an example of the larger issue of what structure do we want at the different layers and how do we want to constrain them. I'll summarize this part. It's really, I want to constrain these layers enough. I want to use layer 3 and layer 4 not in the dumb way we use it historically, which is kind of you open holes in your firewall, but rather let's programmatically set holes for particular service paths that are encrypted, right? And we can take and remove those paths dynamically, because now we have an engine that can set those things. And really, it's kind of how you constrain it enough to do these things. So all this stuff is possible. It's more about a change in awareness of what are the layering and how do you want this to go forward. We haven't made any mistakes, I think, yet, but my point is I worry that people don't understand that this stuff's going to matter for the long term. And the last topic I want to mention is, again, something where we haven't made mistakes yet, but I don't think we're where we need to be, which is federation. So federations, I have 2 meshes. I'd like to be able to use a service that's in a different mesh, right? We have a notion of a gateway proxy that can connect the two, but I don't think we're to the point where that is actually easy to get to work. And you would just say, oh, I have my VMware mesh and my Google mesh, my Red Hat mesh, my Pivotal mesh, and all the services as needed can be exposed to each other and cross-authenticate, cross-discover, right? Know the SLOs, know when to back off, right? Agree on an identity system, right? You can't do authentication if you don't agree on an identity system. Right? So it's not that this is impossible, it's that it's way harder than it needs to be and way harder than people think it is. Right? And by the way, it's easy to have a mesh, but everybody's going to want a collection of meshes. Right? This is the actual problem we have to solve. It's not going to go away, and it's not easy. Right? So I'm hoping we'll get more attention to this problem over the coming year, because I do feel like There's lots of use cases for it, but the driving use case is big enterprises will have different groups will have different meshes, they may be provided by different vendors, they're gonna wanna cross-connect those meshes, right? It's inevitable. And they can kind of do it now, but I don't think we're there. So really, how do we make this work well? For example, do you need multiple gateways? If the gateway fails, you have another way to get to the other mesh, right? What's the failover protocol? Is that sorted out? I don't believe it's sorted out, but I'm stale on this information. If you guys sorted it out, great. Last time I looked, it wasn't sorted out. So the pieces are here. I mean, the concepts are right. The notion of federation is right, but to make it really work is going to be important. So my last slide, and then I don't know how we are on time. We are pretty good on time. Things I want you to get from this: decouple operations from developers, or developers from operations, either way. And that's really about getting stuff out of source code so that we can really let teams just focus on their API and its implementation, and they don't need to know anything about what it means to be a service, honestly. All the service stuff they get for free, including debugging, by the way, and telemetry. Then I want us to think about our structure and try and make sure that we can really do offloading for lower layers, and we can do look-aside, at least for things at the packet header and below. Those will be super valuable. That's an odd set of bullets. I must have hit the key too much, but they're all correct, right? If we have this structure, it enables a bunch of things, and the thing that was supposed to be there is just a reminder that federation is going to matter, and these are the two architectural things I worry about: are this structuring and this federation. Right? Those are things that really have to get right, and we're not quite there yet, but it's also not too late. All right, I will stop there. Thank you so much, and thank you for tolerance on these slides.